Welcome to Homework Help with Jen, and this is going to be a video looking specifically at molecular, complete ionic, and net ionic equations. Okay, before you begin, you should have some kind of a solubility rules chart and some kind of an ion list. All right, now let's take a look at that, and we're going to start out with the reaction between potassium sulfate and calcium chloride. Every time I put out a yellow slip of paper with a step on it, you should consider pausing the video and working that step yourself, and then coming back to it and seeing how I did it. So our first step here is going to be to find the ions on your ion list. Okay, so the first one here is potassium, and I would come over here and I see that potassium is K+. Okay, and now the next one is sulfate, and I would come over here and say, oh, there's sulfate, SO4 2-. And the next one is calcium chloride. Okay, and both calcium and chloride are in my list here. Here I have calcium, Ca2+, and then chloride, Cl1-. Okay, so that was our step one, find the ions on our ion list. Step two is to combine these ions to create formulas. Okay, so we see potassium sulfate, we have K+ and SO4 2-, and so this one would become K2SO4. And then we have calcium chloride, and that one would combine to form CaCl2. Now, my third step is to place the formulas on the reactant side of the molecular equation and the ions on the reactant side of the complete ionic equation. And what I mean by that is we're going to start like this, and I'll say ME for molecular equation. And in a problem like this, so I have these two here like this, and then a yield sign, and that's how we place them on the reactant side. And then we have the complete ionic equation, and I'll put that there. And that will show the ions as they are when they're broken up. So I have K+ plus SO4 2-, and then calcium, Ca2+, and chloride. Okay, now I've placed those on the reactant side. Okay. Now, whenever we begin with one of these, it's usually implied that they are aqueous. So I'm going to do that next very important step where I place my states. A little AQ after each one. And in here as well, remember it is not correct without the states. And the little AQ that I'm making stands for aqueous. Okay. Now my step 4 is to look at the solubility rules to determine if the reaction will form a precipitate if ions switch partners. Okay. So I'm going to come over here and I'm going to look at my sulfate. And the sulfate says that they are soluble except when paired with barium, lead 2, mercury 1, calcium, and silver. And I see right here that I have calcium, and that's one of the exceptions that will make a solid. So the next thing I'm going to do, since I know that that will form a precipitate, is my step 5, which says finish the molecular equation indicating the precipitate as solid. That's that S. So now what I'm going to do is I'm going to see Ca 2 plus and SO4 2 minus. So those will go together, Ca, SO4, and solid. And you have to indicate that it's going to be a solid. Okay? My next step is to finish the complete ionic equation, leaving the precipitate as solid and all else as ions. So what I mean by that is to write down my precipitate under my complete ionic equation as well. CaSO4 solid. And my other ions here that don't change, they remain the same. So we'll say plus K plus aqueous and Cl minus aqueous. Now part of this step is to finish my equation here and to put these two ions together, KCl aqueous. Okay? Now my next step that I need to do is I need to balance it. Okay, so when I look at my molecular equation, I notice that I have 2 potassiums here. And I'm going to need 2 potassiums here. So I will just put a number 2 in front of my potassium there. And then if I come over here, I say, oh look, I need 2 chlorines here, but the 2 in front of that counts for it. And then I see that I have 1 calcium and 1 sulfate, and so that gets to stay the same. So this balancing is just 1, 1, and 1. So you don't have to worry too much about that. That's just balancing as we learned it in chapter 3, where we keep the ions together. But now what I need to do is I also need to balance in my complete ionic equation. And so what I need to write down there, see how I have 2 potassium ions here? I have 1 potassium sulfate, and there's 2 potassiums in that. So then I'm going to put a 2 here. And then it says I have 1 potassium sulfate and there's only 1 sulfate there. So I can put a 1 there. And now I come to my calcium chloride, and I see that I have 1 calcium, but there's 2 chlorides in a single calcium chloride. So this will be 1 because I have that 1 there, and because I have this 2, this will be a 2. Now, the coefficient for this doesn't change, and I still have calcium sulfate. But now I look up there and it says I have 2 KCl. So that means that I have 2 potassium ions and 2 chloride ions. So because I have that 2 there, I need to put a 2 here and a 2 here. So now I have this complete balanced molecular and complete ionic equation. And the next step, step 8, is to write the net ionic equation to show the precipitate. And what we mean by that is that we're going to take the things that are not changing. So first of all, if I look at this, I'm looking to see if I have my pens, but I'm not finding them. Okay. So if you see, look, this 2 potassiums here and 2 potassiums here, those stay the same. So we're not going to include those in the net ionic equation because they are called spectator ions. And then I have the 2 chlorides here and here, so I'm not going to include those either. They are also spectator ions. So then I come down here to my net ionic equation and I write the 2 ions that are reacting, 1 calcium plus 1 sulfate yields 1 calcium sulfate. And that is a molecular equation, a complete ionic equation, and a net ionic equation. The first one shows everything together as units. The second one shows everything that is aqueous broken apart as ions, because that's what it really looks like inside a solution. And the last one shows only the ions that are bonding together to form a precipitate.